So for part two of this video, we know that the integral of 1 over the square root of 1 minus x squared dx is arcsine of x plus c, or sine inverse of x plus c. Okay, but what if it's not a 1? What if it's a squared? So this is very similar to what we just did, okay, with arctan, okay? But for this one right here, what we're going to have to do is we're going to need to make this 1, right? So what would be the integral of 1 over the square root of a squared minus x squared? Okay, that's the question that's being asked. So we're going to take the integral, okay, and we're going to modify it, right? So we're going to have 1 over the square root of a squared minus x squared, okay? And we're going to want to multiply, but we want to get this to be 1. But the only way to get this to be 1 is to multiply by another square root, right? So the only way that we're going to be able to do this is to multiply by the square root of 1 over a squared, because I need to multiply the a squared by 1 over a squared, but that's inside a square root. So I'm going to need to multiply by another square root to get that to happen. So I'm going to multiply by 1 over a squared, the square root of 1 over a squared, over the square root of 1 over a squared, because this is 1 right here. Okay. All right. So basically it's this idea that you need to know that if you take the square root of a times the square root of b, the only way that can happen is you have the square root of a times b, okay? So the only way to get to multiply square roots together is to have two square roots, okay? All right? So now when we multiply this out, okay, it's going to be 1 times the square root of 1 over a squared. So this is equal to the integral of the square root of 1 over a squared over. When I multiply these, because they're both inside a square root, I'm going to be able to distribute this with this. The 1 over a squared times the a squared in here is going to become a 1. So that's a square root of 1. And then minus, right, minus. And this would be x squared over a squared. And still the square root, okay? And then dx, that's still under the square root, okay? So now we're going to be able to rewrite this one and rewrite this one, because the square root of 1 over a squared is the square root of 1, which is 1, over the square root of a squared, which is going to be a, okay? So this is equal to the integral of 1 over a over, and then the square root of 1 minus x over a squared, and then dx. All right, this 1 over a right here, hold on. If we let u be x over a, what I was going to say was incorrect, so that's why I stopped saying it, okay? So another way of saying this is 1 over a times x, okay? And the derivative with respect to u, right, with respect to x of u would be 1 over a dx. So du is going to become 1 over a dx. Okay, so I was gonna see what I was going to say is that you bring that out, but that's not correct, because we need this 1 over a with the dx to make our du. Okay, all right. So we don't want to bring this 1 over a out. Okay, we actually want to combine it with the dx to make our du. So this is going to become. I'm going to slide this up a little bit. All right. So the 1 over a and the dx make up my du. And this is going to be 1 minus u squared, right, under the square root. So this becomes the integral of 1 over the square root of 1 minus u squared du. And now it looks like the original one that we had up above, right? Except for instead of x, we have u, okay? So that would mean this is equal to simply the arc sine, or sine inverse, okay, arc sine of u plus some constant c. But what is u, right? U is x over a, okay? So this is equivalent to sine inverse of u plus c, or sine inverse of x over a plus c. So unlike tan inverse, you don't have something that you have to multiply by out in front, right? There's no constant out in front you're multiplying by. It's just going to be your x over your a, okay? And so the general form of this, okay, when you see the integral of 1 over the square root of a squared minus u squared du, this will always equal the integral, or not the integral, the sine inverse of u over a plus some constant c. It's always that, okay? Now, this u is where our x is going to be. So this can be different things. It can be x over 2. It can be x plus 5, okay? But this, where your u is where the x is going to be, okay? All right? So let's look at some examples with this. So for example 5, we want to integrate 1 over the square root of 1 minus x plus 7 squared, and then dx, all right? So we got to recognize this is taking on the form of 1 over the square root of a squared minus u squared, okay? So this would be equal to the integral of 1 over the square root of, okay, so what are you squaring to get the 1? Well, it's 1 again, right? So 1 squared minus x plus 7 squared. Extend my square root in my fraction bar, and then dx. Okay, so you can tell from this that your a is 1 and your u is x plus 7, right? Okay, so then this would be equivalent to sine inverse of your u, which is x plus 7, over your a, which is 1, plus your constant c, right? But x plus 7 over 1, there's a better way of writing that. That would just be sine inverse of x plus 7 plus c. Okay? And that's how you integrate this one. So for example 6, okay, we want to integrate 1 over the square root of 16 minus x plus 3 squared dx. Again, it's recognizing it's of that form, right? The square root of a squared minus u squared, okay? So this is the integral of 1 over the square root of, okay, so 16 would be 4 squared. So 4 squared minus x plus 3 squared. Okay, and so a is going to be 4, and our u is going to be x plus 3. All right, so that means this is equivalent to sine inverse of your u, which is x plus 3, over a, which is 4, plus some constant c. Okay, now that's the answer to this. Okay, now our job is to, when we recognize it, when we don't have a perfect square like this, okay, we want to rewrite it so it looks like this. So our job, and this is where it gets harder, is, okay, we want to rewrite it so it looks like this. Okay, how do we do that? All right, and that we got to use completing the square, and that's the next few examples. Okay, all right, for example number 7, we want to integrate 1 over the square root of negative x squared minus 2x plus 4 dx. All right, so the way we're going to pick up a negative, okay, or the subtraction part of this, is we're going to factor out a negative out of all 3 of these terms, okay? And you're going to see that's the minus, the subtraction part is going to develop from factoring a negative out, okay? All right, so this is equivalent to the integral of 1 over the square root of, and then here we're going to factor out a negative, okay, a -1 or a negative, and then times, and it'd be x squared plus 2x minus 4. Close the parenthesis, extend my square root and my fraction bar a little bit, and then dx. Okay, so now I can look at this and go, all right, I can complete the square on this, all right? And so I know I have an x squared, okay, and then building off that to complete my square, I need the right side and the bottom of the x squared part. And these are my x's again. So what goes here and here is the half of the 2x. So half of those 2x's are going to go here and here. So that would be 1x and 1x. So these two sides would have to be x by x to get the area of x squared. If this is x, this would have, and the area is 1x, this would have to be +1 and +1. And +1 times +1 is +1. So this is the missing part right here, right? It's +1 to make this square. All right. So we have right now -4. So we need to add 1 to this, right? We need a 1. So this is equivalent to the integral. We got to keep writing this, 1 over the square root of negative parenthesis x squared plus 2x plus the 1, right? And I forgot to write the 1 there. 1. So plus the 1, but the problem is I no longer have -4, right? So what do I need to add, what do I need to put here to make it still be -4? Well, I need to put -5 because 1 and the -5 make up the -4, the -4, okay? And then dx. Okay, so then these three pieces right here make up this perfect square, all right? So these three pieces right here. So this is equivalent to the integral of 1 over the square root of negative parenthesis, and this would be x plus 1 squared, okay? And then this -5, right? But we got these three pieces, we make up the x plus 1 squared, but we still have this negative of -5, right? So that would be +5. So that's why we're going to put +5 right here. And then dx. And again, how did I get that +5? Well, it's -5 in the parentheses, but there's a negative on the outside of here, right? So that's taking the opposite of -5, which is actually +5, so +5. Okay, the order isn't right, correct? All right, so we need to rewrite this, okay? So it's not taking on that form of a squared minus u squared yet, okay? So this would be the integral. I'm just going to do this in some simple steps, okay? So this is be the integral of 1 over the square root of 5 minus x plus 1 squared. And see, we got the minus from very beginning, factoring out the negative, right? Okay, and then dx. Extend my little square root bar a little bit. Okay, now this doesn't look like a perfect square, right? 5's not a perfect square. Well, what would you square to get 5? Well, you'd have to square the square root of 5. Okay, so once again, we have to do this little simple thing of this is 1 over the square root of the square root of 5 squared minus x plus 1 squared. Extend my square root and my fraction bar, and then dx, right? Okay, I'm going to slide this up just a little bit. All right, so now from this, I can tell my a is the square root of 5, and my u is x plus 1. All right, and it's taken on that form of a squared minus u squared, right? Okay, so this would be sine inverse of my u, which is x plus 1, over a, which is the square root of 5 plus some constant c. Okay, so now this is a correct answer. It's the right answer, but it's not the best answer because I need to multiply the top and bottom by the square root of 5. So this is sine inverse of the square root of 5 times x plus 1 over 5, because I'm multiplying the top and bottom by the square root of 5, plus your constant c. And that would be the correct answer for this one, okay? Let's move on to the next example. All right, for example 8, we want to find the integral of 1 over the square root of negative 3x squared plus 12x plus 3, and then dx. All right, so, okay, to get the sign inverse, these x squares are always going to have to be negative, okay? But this time it's just not factoring out a negative. We're going to have to factor out a negative 3 from all three terms, all right? So that's the first step that we're going to need to do, okay? So this is equivalent to the integral of 1 over the square root of negative 3 times, and then what would be left in the parentheses is an x squared, and then minus 4x, and then minus 1. Extend my square root and my fraction bar, dx, right? Okay. Now this is going to be a little bit different, okay? Because we want this to be just minus something squared, right? Not minus 3 times something squared. So right off the get-go, we're going to need to rewrite this, okay? So this is equivalent. Well, this is you could also look at this as being negative 1 times 3 times this parenthesis, okay? So what we have to do is we have to break this 3 out of here, okay? And so let me show you how we're going to do a property that we've already used today, okay? So this would be 1 over, and this is going to be the square root of 3. I'll talk about this in just a minute. Square root of 3 times the square root of negative parenthesis x squared minus 4x minus 1, close the parenthesis, extend my square root, extend my fraction bar a little bit, and then dx. Okay, so what I used here was if I have the square root of a times b, that can be broken up into the multiplication of two different square roots. So the square root of a product is the square root of a times the square root of b. All right. So really what I have is I'm looking at this as 3 times negative square root of x squared minus 4x minus 1. Okay. So because there's this 3, that's a product, right? 3 times all of this. Okay. I can break that up into square root of 2 individual things. All right. Like I did here. Now, what's going to be helpful is now because of this, I can bring this all the way out into the front, okay, of the integral. And that's what I'm going to do next, okay? So this is the equivalent of 1 over the square root of 3 times the integral of 1 over the square root of negative parenthesis x squared minus 4x minus 1, close the parenthesis, and then dx. Okay, now is where I'm going to start completing the square, okay? So I have an x squared. Okay, and off to the side, I'm going to put half of my x terms in each of these. So half of negative 4x, that'd give me negative 2x and negative 2x. Again, I'm doing half of negative 4x, right? And then this would be x, and this would be x, and minus 2, and minus 2, and negative 2 times negative 2 is positive 4. So what I need is a positive 4 to make this a perfect square. But I don't have a positive 4 here, right? So I'm going to break the negative 1 up, okay? I'm going to decompose it, all right? So this is 1 over the square root of 3. The integral of 1 over the square root of negative parenthesis x squared minus 4x plus the 4, right? But here's the problem. that's not -1, or that's not subtracting 1 anymore, right? So what do I need to do to this to make it right? I need to subtract 5. Because what's 4 and -5? Well, it's a -1. So I still have this -1 right here, right? It's just I broke it up into 4 and -5. Extend my square root, extend my fraction bar a little bit, dx. Okay, so now then, these three terms are going to make my perfect square, all right? So this is 1 over the square root of 3 times the integral of 1 over the square root of negative parenthesis, and these three terms make x minus 2 squared. Now, I brought those out of the parentheses, right? So I don't have -5, I have negative of -5, right? So it becomes +5. And then dx. And then the order is not correct, so I'm going to rewrite the order. So this would be 1 over, I'm going to slide it up a little bit too. 1 over the square root of 3. The integral of 1 over the square root of 5 minus x minus 2 squared. Okay, it's not of that form, a squared minus u squared yet. Okay, so this would be equal to 1 over the square root of 3 times the integral of 1 over the square root of the square root of 5 squared, because the square root of 5 squared is 5, minus x minus 2 squared. And now we have that form that we need, right? So this is our a, and this is our u, and I forgot my dx. In fact, I forgot the dx on the last two steps. So right here, let's put a dx there and a dx here, okay? All right, so our a is the square root of 5, and our u is x minus 2. Okay, and we use that to take this integral, right? But in front we have 1 over the square root of 3. All right, so this is equivalent to 1 over the square root of 3 arc sine, or sine inverse, right, of our u, which is x minus 2, over our a, which is the square root of 5, and then plus our constant c. All right, now this is a correct answer, all right, but it's not the best and final answer, okay? So this one right out here, we need to rewrite this fraction right here as we need to multiply, we need to rationalize the denominator. That's what this is called, okay? We're going to multiply the numerator and denominator by the square root of 3. So we wind up with the square root of 3 over 3 arc sine, you could also be writing sine inverse, of multiply this by the top and bottom by the square root of 5 over the square root of 5. So that'd be the square root of 5 times x minus 2 over 5, and then plus your constant c. Okay? And that is how you integrate, with the result being arcsine, okay? All right, so there's two new basically formulas you need to know, okay? Antiderivative formulas you need to know. One is the integral of 1 over a squared plus u squared du, and also the integral of 1 over the square root of a squared minus u squared du. Okay, so those are two new tools that you have in order to find integrals, okay? All right, guys, so I'll come back in just a second with the assignment sheet, okay? And we are done with this unit. This is the last lesson of this unit. All right, guys, so what I want you to do is assignment 8-8, which is worksheet 8-8 in your packet, okay? It's integration techniques, completing the square, okay? And today is the 30th. Don't worry about filling this out. This is just for me and just for you to see the assignment, okay? It's gonna be worksheet 8-8. So good news, guys. So so right now we're supposed to be back on May 4th, okay? So our AP exam is May 5th, all right? So right now I am planning for us to take the full-blown exam on May 5th, okay? That may change, but I'm gonna prepare you right now for the full blown exam. And I personally, right now, I need to do a little more research on this, but I think it's more advantageous to us if we take the full blown exam, because right now they're talking about a 45-minute exam. They're, in my opinion, they are going to ask you the hardest calculus questions for that 45-minute, because they're going to make sure that you know calculus before they grant you college credit. Okay. So I just think they're not going to have some simple ones and some hard ones. They're going to be all hard if they're only going to ask you, do a 45-minute question, and it's all written response. There's no multiple choice on that. Okay. As of right now, I'm going to know more. They're going to have a conference with all the AP teachers on April 3rd, and they're going to come out and let us know exactly what's going to be going on. All right. But I'm keeping abreast of everything. The College Board, everything's changing drastically. But here's the good news: we're ahead. Okay, so last year, I'm looking at when we did this. We did this on April 3rd last year, so we are right on track with where we've been the last couple of years. Okay, so just hang in there. All right. I miss you guys, and I wish I could see you guys. But hopefully these videos are really helping you out, and just take advantage of this. Okay. Again, I'm planning on taking the full-blown exam. Okay. I really would like you guys to take the full-blown exam. I think you have a better opportunity to show what you know with a longer exam. Okay. All right. You guys take care. I'll see you with the next lesson. All right. Bye.